Okay, so let us go to this part, the third video, video 3, okay? Covering these questions here. So we pause the video and you can write the question and follow, okay? So here, write with the neat diagram, define the following terms. So let us do that. Let me draw a diagram and you listen carefully. Now, yesterday we have learned that there are two types of spherical mirror, concave and convex. So concave is that type where it is cut out of the mirror and the inside of the spoon side reflects light. In other words, that is the side from where you can see your image. So this is the mirror here. See, for example, this one. Then the bulging outside do not reflect light. So we put it on the bulging outside, this side do not reflect. So there will be the lines, oblique lines. And the reflecting side is facing left. Now before this was taken out, you know it was part of a full ball, right? Part of a full ball before this mirror was cut out. Before this mirror was cut out, made a concave, it was like this, part of the full sphere. Like this, sorry. And then this part has been removed. So this removed part, we indicated by the broken lines. Then we know here, you can put a line halfway, and then the other mirror is such that the bulging outside here, see, this side, like the outside of the spoon reflects. So there should be no line on that side. And the line means non-reflecting is on the curving in part. So that is called the convex. So we learned that yesterday. So this is convex and this is concave mirror. The two types of spherical mirrors. Now, before you took out this mirror or that mirror, this was part of a sphere and it had a center here, centermost point. The middle point, which will be inside the hollow sphere, means this one somewhere here. Mark the point as C. And here also it was part of a full sphere before it was brought out like this. So it had a center, so mark that. So that we cannot see because there is an imaginary centermost point inside the sphere. So that point, center of the sphere, center of this sphere, from where you cut out a concave, or center of the sphere from where you cut out a convex, that center point is called the center of curvature, denoted by capital C. Okay. And next, you take your concave mirror and mark the middle point. Means the middlemost point, the center point of the reflecting surface, which will be this from here to here is mirror, means middle will be somewhere here. So that middle point that I've actually marked here is called the pole. So if it were a convex, then this point here, this point, the mirror runs from here to here. So the exact middle point inside the mirror, on the mirror, not inside, on the surface of the mirror, is called the pole of the mirror. So we have defined this A and B, pole and center of curvature. Now you take a scale pencil and draw a line passing through this point here, the 2 points called C and P. The straight line passing through this C and P, in both you can draw. And then once you draw, you look here. Straight line passing through C and P, this line is called the principal axis. Principal axis. So the straight line passing through C and P is called the principal axis. So we have learned 4 new terms today. The pole, center of curvature, sorry, 3 so far, principal axis, and 1 more. So these are very important, okay? Now, if you were to mark this point here, this distance, okay, I will just ask you to mark above it. Let me just here, okay, so here, the distance between this point C, center of curvature, and this point P, the pole, is this one. This distance here, for the concave mirror given here, from here to here, the length. And here, if you were to mark the same thing, then the distance between C and P would be this one. So this distance here between C and P, running from here to here, this length or distance is called radius of curvature, capital R. Radius of curvature is the distance between C and P. Or another way to describe it is simply the radius of this hollow ball, from where this mirror is cut out, radius of the ball, radius of the sphere, from where this mirror is cut out, it's called the radius of curvature. Like that also you can define, okay? Means middle point, join it to any point on the surface of the ball, that is the radius of the sphere. So the radius of the sphere, from where the mirror is cut out, or the distance between C and P, which is the same, is called radius of curvature, okay? So we have learned 4 terms which are important. Pole, center of curvature C, denoted by capital C, radius of curvature capital R, and principal axis. Without these 4 things, the concave and the convex mirror you use will be meaningless, okay? You cannot draw ray diagrams, so you need to absolutely be clear about this, okay? So you can get the definition on your note, tuition note. So you read them, you'll understand yourself. Now let us, once we've done this, let us go to question number 18. Now, in 18, we are supposed to answer some questions. Let us see them. Answer the following questions by using question number 17 that we learned just now. Pause the video and write down this one. Then rejoin again, replay it and join again, okay? So here, these points are going to be very important. That's why we put it here. Now, look here. Before you go and answer this question, let us do this exercise. Below this, what you've written, you write down on your notebook, tuition copy, the one you're writing, okay? That is going to be very important. You follow me and draw a concave mirror here. And we know concave means like the inside of the spoon is reflecting. So there should be no line on that side. So this is concave. Then below this, so this is your concave mirror. See here, I'll just take a real concave mirror maybe. And we can do. Yeah, here is a concave mirror, real one. If you touch this surface where you can see your finger, that side is like the inside of the spoon, concave, okay? And then we need a convex also, so let us just be ready with it. Okay, so here, concave. So I'm holding the mirror. The side from where you can see your face is this side. This blue side is the non-reflecting side, where we cannot see our face. That is denoted by the lines here, okay? So the mirror is like this. Blue is on the facing right side, and the reflecting surface is facing left side, like that you hold. Now, if you were to take this same mirror and do it ulta like this, then your mirror will become same mirror. This is still concave mirror. You know that this is the same mirror, concave, but the position will become like this. This time, this same mirror is still it's concave. See here, like the inside of the spoon. Both are correct. Okay. Then you take the convex and do likewise on the right side. Here, this is now bulging out the reflecting side. Non-reflecting side is like the inside of the spoon now. So that is called convex mirror. So let us draw here this mirror. So it's facing like this blue side on the right and reflecting side on the left. This one, this diagram. So this is convex. Now take this mirror and flip it like this so that the reflecting face faces towards the right now. So you did from here to here means simply this mirror is ulta. So now it would be like this. It is still convex. Same mirror, bulging out. The reflecting surface is bulging out. Both are correct. And you can use like this convex mirror. You're using like this, looking at your face like this. Non-reflecting, reflecting. And I'm looking at my face. This is the one. If I go like this, and then now facing left, I can use it. I can see my face still. In real life, we can use both ways like that. With my object face on the left, on the right, and with my object face on the left like this, on the right, like this. We can use. But in this chapter, we are not going to use our mirror like this. We are going to use like this. You also remember that, okay? So same rule apply here. I can use my concave now. This is the concave now. Now this is the one. The reflecting surface is facing left side. So my face object should be on the left side. Okay, so we should use like that, just like this one. We can also use like this, like the second case. Now it's like the second position, but we will intentionally not do like that, okay? So once you settle that, now look here now. So this is the ball. the full ball. So the center of curvature is this one. This is the correct way of doing it. So let us do the center of the ball is this one. Pole will be this one. We know now the middle point of the mirror is there. So we are going to use like this. Now we can answer our question. Now pole P of the spherical mirror in both cases lie exactly on the reflecting surface. Yes. See here, the pole is this one, middle point, on the surface. Concave, you take, it is an actual point on the surface. So this is correct. Okay, always pole will be on the surface. Now, we are not allowed to use like this. Now it's clear. Okay, so we are not allowed to use like this means, okay, just leave it. This one, so here, in that first case, up here and here, so C means center of curvature is not a part of the reflecting surface. That is, it does not, of course, it is part of the definition. What they mean is it do not lie on the surface of the reflecting surface like the pole. Yes, C is far away from the surface of the mirror, outside the surface. So this is also yes again. In both cases, C is outside the surface, meaning not touching the surface. Now these 2 points very clearly know. Since we are allowed to use our mirror with the reflecting surface facing left, so that my object has to be on the left, and I should not use mirror convex also concave also, so that reflecting surface face right, so my object has to be on the right. We should not use like that. So this is settled. If such is the case, then C will lie in front of concave. Yes, C. This is the mirror means front side is always left. Now front or left is same. So C is on the left or front side of a concave mirror. Yes. And then C will always be behind or on the right side. Behind means right side of the convex mirror. Yes. So remember those points, okay? Now once we're through with that, then we'll go and define an important term. 17, 18 done. I'll go to 20, okay? 20. Write it down, draw this figure and keep in your mind and put this wrong sign, right sign, wrong sign. Remember never to use your mirror like this in this chapter because we are following this convention, means this rule, okay? So next question number 20. Follow and write with me on your tuition copy, question number 20. With a neat diagram, okay, with a neat diagram, define principal focus. Define principal focus, FOCUS, or it is simply called focus of a spherical mirror, okay? Now here, follow me and look at the diagram and draw. Now, just now we learned, so draw your concave on the left-right divided margin, and then on the left side you draw maybe concave, draw a straight line with your pencil scale, and if you have a compass it will be good. From the next class, please be ready, video 4, be ready with your compass, pencil, rubber and all, okay? We'll need it for drawing ray diagrams. Now you draw your concave. We have decided to put the oblique lines always on the right, so the reflecting surface face left, so object will be left. Just now we did that. We have decided not to do like this, concave facing reflecting surface facing right. Just now we did, so keep that in mind. So if that is the case, where will C be? Very easy. The ball is like this, right? So C will be inside the ball somewhere here. So mark the distance. Then, whatever distance, this middle point is called the pole, and the line passing through C and P is the principal axis. And this side also you draw a convex mirror. Just draw a line first. With compass, you mark here C, and maybe 6 centimeter or yeah, something like that. You just draw this from here, compass. Then this convex, bulging out. Chuli concave or convex also. The the line side, like the chuli side, always on the right. Okay, convex also, concave also. So that no chuli side should face. No chuli means reflecting surface face left. Okay. Now, so this is your pole. Mark it, this point. Now, you pass the light ray. So since it's facing left, the ray has to come from the left. There is no point passing light ray on the non-reflecting side of a mirror, torchlight on the, no. Mirror means light should be passed on the reflecting surface. So pass a ray, and then the condition is, before that you took here 6, let us say. So half of this you mark it, just half. Half of this, just mark it. Don't mark any label, just mark it and keep. Draw a ray parallel to the principal axis. Means this is called the incident ray. We learned in our first video. The first ray that is passed onto the mirror is called incident ray. So once it strikes the mirror, this ray parallel to the principal axis will bounce back, because the only job of a mirror is that light will bounce back. So it will bounce back and let it go through this point you have marked. Okay, so here, this ray that has bounced back just now is called nothing but reflected ray. Don't forget to put the arrow. Incident ray direction from left to right. Reflected ray will be opposite because it's bouncing back, right to left. Okay, then pass another ray above or below, up to you. Parallel to principal axis again, parallel to the principal axis. Incident ray. Then this ray also will bounce back. Let it bounce back. And after it bounce back, you will find out that, interestingly, this is the reflected ray. Don't forget to mark the arrow. The two reflected rays meet at the same point, which is on the principal axis, not outside, on the principal axis. The two reflected rays meet at the same point on the principal axis. That point. So now look at this ray. The reflected rays are like two aeroplanes going into the same airfield. That means converging, that is called converging. Then diverging means two aeroplanes coming out of the same airfield going away from each other. It's called diverging. But two aeroplanes coming from far distance apart nearby to the same airfield, that's called converging. It's converging to the same point on the principal axis. That point is called principal focus, or focus, denoted by capital F. Okay, so focus means the point where the two reflected rays meet, the same point on the principal axis. Okay, so here the two reflected rays converge to the focus. Therefore, concave mirror is also called converging mirror, because they converge parallel incident light rays to the same point, to the focus. Then let us do the same experiment. You have to pass the light ray again parallel to principal axis from left to right, because the reflecting surface is on the left. If you pass the ray from here, there's meaningless, because this side will not reflect. Chuli side is non-reflecting, so that's not allowed. So once you do that, now this bulge is carving inside, this convex is outside. So like this, reflection will take place, but opposite manner. Here that same type of rays bouncing inwards. Here it will bounce outward. Put your scale here and here. Okay, and then follow me here. Now, in front of the mirror, left side of the mirror, you draw one full line. Don't move your scale, same straight line, draw broken lines on the right side of the mirror, like this. So this ray, parallel to the principal axis, will reflect like this. Where did this ray come from, reflected ray? It came from here, left side. But it will look as if it's coming from this point on the right, because of the straight line. So this ray look as if it's coming from this point. Is it coming from this point? No, it's coming from here. So this is not a real point, as if point. Okay, then draw another ray like that, parallel to the principal. This is the principal axis, this line. Draw parallel. So this is the parallel incident ray. Put your scale here and here again. And then draw broken lines on the right side of the mirror. This side, right side, and left side you draw full line like just you did. Same straight line. This whole thing should be on the same straight line. So this ray after hitting mirror will actually bounce back outwards, opposite to the concave. It's bouncing inwards, but because the curve is opposite, it will bounce outwards. See, these two rays. And these two rays look as if, I said as if, they're coming from the same point on the principal axis. Are they coming from here? No, they just look as if they're coming from this point. That as if point is called principal focus of a convex mirror. And because the two reflected rays are, look at the arrows, are now going more and more away, diverging away. The two reflected rays are diverging. So convex mirror is sometimes called diverging mirror. Okay, diverging mirror. Now one more point here. Okay, diverging mirror. Now here. Now here the two reflected rays actually really go to the focus. So we say concave mirror has a real focus. The focus is real because the reflected rays are actually going there. But in this case, the two reflected rays look as if they are coming from the focus. They are not coming from here. They are coming from the focus. They look as if they are coming from here. This is not a real point. This is as if point. So this focus is called virtual focus. And we will say convex mirror has a virtual focus because the reflected rays look as if they are coming from there, but they are not actually coming from there, right? So there. So virtual means something that looks so real, but it's not actually real. For example, you put a pencil in a glass of water, your pencil looks bent, right? You have seen that already. Now the question to be asked is the pencil bent? No, but it looks bent. So that looks bent is not real, that's virtual. Virtual means something which looks like that, but it's not actually like that in reality, right? So this is the definition for principal focus. So we can write it down here. Follow me. Incident rays. Okay, incident rays. Let me just write this a little bit above. This is convex. Okay, so incident rays running close means nearby. Okay, close means close, and parallel. This is important. Parallel to close and parallel to the principal axis, to the principal axis means the line. Okay, principal axis converge to a point. Converge to a point. Look here in the case of, so in bracket you write in, we're talking about the case of a concave mirror. In the case of a concave mirror, they converge. See, the reflected rays converge. Incident rays running close and parallel to the principal axis converge actually to a point, really to a point, in the case of a concave mirror, or appear to diverge, from a point. Okay, see here the two reflected rays appear to, as if, or appear to diverge from here. They are not coming from there. Therefore we use appear to diverge from a point in the case of a convex mirror. So in the case of convex mirror, the reflected rays appear to diverge from a point. In the case of concave mirror, they actually converge to a point. Okay, that point is what, comma, on the principal axis. Principal axis. So in the case of concave mirror, the reflected rays converge to a point on the principal axis. In the case of convex mirror, they appear to diverge from a point on the principal axis. Both are on the principal axis here. F is on the principal axis. F the. After what? This happens after reflection of the parallel rays. After reflection. Full stop. After reflection. After this point is called, this point is called principal focus. This point is called principal focus, capital denoted by capital F, or focus, you can say like that. So that is the definition for principal focus. It is a point on the principal axis. Okay. Then this question also says, with a neat diagram define principal focus or focus of a spherical mirror, and also focal length. And so here we write here at and focal length also, let us define it. So continue. Now take your pencil scale and mark this distance between this principal focus capital F, this is a point, and this P. So this point distance between capital F, principal focus, and pole of the mirror, this distance is called small f. Just now we learned this one, right? The distance between C and P, we already learned in 17, I think. But this distance is actually called radius of curvature. So this distance here between P and F here, this distance is called focal length, small f. And the distance between this P here and this C here, we already know this is called the radius of curvature, capital R. Right? So this is what we learned. So principle, a focal length is the distance between focus and pole. That is called the focal length. So we have learned that. Now let us go and read here question number 21 or 22 first. 22, then we'll come back to 21. Now read on the question. Question number 22. Okay. What is the relationship between, what is the relationship between, okay, relationship between radius of curvature, I'll just write in short, R, and focal length, so small f. Okay, so just write this one. Now by experiments it has been found out that this focal length here, distance between P and F, or this radius of curvature here, R capital, distance between C and P, it has been found out that this is double of the small f, 2f. That meaning if this radius of curvature is 20 centimeter, f is always 10 half. So radius of curvature is 2 times f. That has been found out. Here also R is always 2 times f. That has been found out by experiments that this is always true. So relationship answer is this one. R is equal to twice f, or you can also say f here equal to R by 2 or 1 by half of R. See, this 2 will go here now, 1 by 2. Come down. So this is the relationship. R equal to 2f you can write, or f is equal to half of R. Remember, focal length is always half of radius curvature, or radius of curvature is 2 times focal length. That's the relationship. Final question 21 before we close. Now right here, question number 21. What is aperture? Final term for a mirror here, aperture of a spherical mirror, Now let me just explain it to you with this here. You can also draw it. This is the concave mirror, let us say, or convex, let's say concave. Then the outer ring here, you draw it. So I'm going to outer ring of the mirror, outer boundary of the mirror. That means you draw it. Okay, this one here. Okay, so this one you draw, and then this center is here. Circle, it is a circle. So here you draw here the distance from here to here. That is called the diameter. This is the diameter. So the diameter of the outer rim of a spherical mirror is called its aperture. In other words, the reflecting surface area available, big, small, is called aperture. The actual definition of your text is the diameter of the outer rim from here to here. What is the diameter? Not this curve, but the circle outer rim. Its diameter is called aperture. In other words, this mirror here, concave, the rim is only around this much circle, so diameter is small. But if this is also a mirror, then see here, you can put it inside also. So here, see, the aperture of the inside mirror that I've placed is only this much diameter. The other one, yellow one, is bigger diameter. So we say this will have bigger aperture, smaller aperture. In other words, in simple language, the total area available for reflection, okay? More means more aperture, okay? That's the simple language. But textbook definition is diameter of the outer rim, so we can write it down. Diameter of the outer rim, R-I-M, rim, of the outer rim or circular rim. Okay, just add the word outer circular rim. Circular rim of a spherical mirror is called its aperture. That's the definition. So that concludes the questions for this video. Okay.